Good morning, everybody. Speeding at sea, it's me, Z. I hope everybody has been having a spectacular morning, evening, afternoon, whatever time zone it is. Um, First of all, thank you so much for 900 members in class. That's crazy to think about. That's two huge lecture halls, maybe even three huge lecture halls if you think about it. Another piece of information you guys might want to know is that I woke up with a little bit of a sore throat, so my voice is not at its prime just yet, but I have with me right now a warm glass of, oh, I guess I can't even show it. It's a warm glass of chamomile tea. Yes, good morning, PogCham Senpai as well. Actually, about that, Eggy drew a series of really adorable Orbeez and Shibe mascots, and I will be including them below. One of them is in the corner right now. It's called the Shibe. It's like a Shibe with a Z, but now I'm realizing how to pronounce it. Zybe? Maybe a Zybe is the right way to say it. Also, I hope you like my new outfit. I announced this at the last stream. If those of you did not catch it, I have a series of new outfits, including this new Galaxy hoodie and a new Moon hoodie as well. But I will be trying this one out for today, so I hope it looks very nice. Alright, so I hope you guys have a nice warm cup of tea. If anything, I've gotten over my jet lag, but in exchange, I have also become very addicted to coffee, so not very good combination, but I think things will even out over the next week or so. That is really refreshing. Alright, let me go through class attendance. If you're here, please be sure to say here, but I'll go from the top. Hello, Charney. Hello, Luna's Emmy review materials. I will definitely check out your channel afterwards. That is a really interesting title. Hello, Eggy. Thank you for the cute doodles. Hello, Crypta. Hello, PogCham Senpai. Hello, Faye. If you guys haven't checked out Faye's channel already, she's a biology VTuber, my VTubing friend from the very start. So please be sure to check out her channel. She does amazing content. Hello, Shizius. Hello, Alexander Babsky. Hello, PogCham Senpai. Hello, Sarah John. Hello, Mino. So many members of class today. I don't know if this time works better for people. I know for our Central European time zone folks, this is probably more preferred. I will have a stream actually tomorrow, now that I think about it, at roughly 11 a.m. PST or 12 p.m. PST. So I hope those times also work well for you guys as well. I know there were some Orbeez last stream who said they were there at 3 a.m. their local time for my stream, which, if that was the case, thank you so much. It means so much for you guys to be present and to be sacrificing your sleep. Like, wow, that's really impressive. Hello, Don Quixote. I'm finally here. Yes, it's so glad to have you guys in class. And I might send out a poll maybe after these first 2 weeks or so to see what times work for you guys as well. Oh, thank you for complimenting the bracelet as well, Crypta. If you guys don't notice, I think there's a small bracelet on this hand. Whoop. Yeah, a little tiny one. My arm is also a little bit glitchy, but hopefully that'll be alright. Project Moon. Hello, Akun. I am actually a physics VTuber, but I'm learning machine learning with this new Google course that was released, and it's really nice. So just wanted to start learning something together, and please feel free to also suggest other accessible courses. We might be able to do a series after this one that will delve into another topic, who knows. Alright, without much further ado, let's get started. And as we get started, please be sure to maybe message what is your default drink in the morning, because I'm drinking this nice chamomile citrus tea to hopefully calm down my throat. And hopefully it's back in peak condition within the next few days. I've also linked the course in the channel. So let's get started. Oh, this is actually the programming exercise. I've opened that up in a new tab so that we can start. Ooh, water, H2O. Okay, the defaults, the most chemically simple ingredients. Coffee, yes. No, I've been drinking way too much coffee. So the cafe I'm at has the pumpkin spice latte ones, but they also have this new pumpkin pie latte, which has also been very delicious. Red tea. What is red tea made out of? That's really interesting. I better give that a try. I've been honestly defaulting to matcha as well. I'll show you guys some of the matcha powder that I bought in Japan. It is very delicious. All right, let's get started. Classification. Determine an approximate. First, let me add a stream marker. Okay. All right. The learning objectives. Determine an approximate threshold for a binary classification model. Calculate and choose appropriate metrics to evaluate a binary classification model. Interpret ROC and AUC. So in our last courses, we went over linear and logistic regression. As you guys may recall, it's been about a month since my last stream, so we will definitely need a bit of a refresher. So we're going to walk through this course a little slowly to make sure we have all the concepts down. So in the logistic regression model, you learned how to use the sigmoid function to convert raw model output to a value between 0 and 1 to make probabilistic predictions. For example, predicting that a given email has 75% chance of being spam. But what if your goal is not to output probability, but a category? For example, predicting whether a given email is spam or not spam. Whenever they say spam, I keep thinking of like the ham. And just as a refresher, I remember the sigmoid function was when there was a function that went from 0, so 0, and it sort of went up to 1, like that. That was a really useful way of determining probability, but I guess for this course we're determining a set of classes. So we'll be first predicting a set of classes as an example belongs to. In this module, you'll learn how to convert a logistic regression model that predicts a probability into a classification model that predicts one of two classes. You'll also learn how to choose and calculate appropriate metrics to evaluate the quality of the classification model's predictions. And then we'll get an introduction to multi-class classification problems, which are discussed more in depth. I see. So we're taking the sigmoid function, which was probability, and somehow converting that into two classes. That's really intriguing. So let's go on to the next part. Oh, and let me read through a few comments. English breakfast tea. Ooh, that's really delicious. If you guys haven't been to Fortnum and Mason in London yet, I highly recommend. They have amazing teas, and their caffeinated teas just hit home so much. I think my favorite one is called the Smoked Earl Grey. It has this really deep smoky flavor. I need a better GPU to properly study machine learning. Oh no. Well, this course is just a website. So even if your computer is an absolute potato, you can start with this course. Hello, KK1. Yes, I am doing this course at a bit of a different time so that many of you guys can visit. And yes, I am back, which is very, very exciting, though I have to admit this first week of being back has been absolute chaos, which is why my voice has been a little dead recently. Okay, let's read through the course. Thresholds and the confusion matrix. Let's say you have a logistic regression model for spam email detection that predicts a value between 0 and 1, so it predicts a probability, representing the probability that a given email is spam. A prediction of 0.5 signifies a 50% likelihood that the email is spam, and so forth. So we're using this probability to actually categorize spam or no spam. You'd like to deploy this model in an email application to filter spam in a separate mail folder. But to do so, you need to convert the model's raw numerical output into one of two categories. To make this conversion, you choose a threshold probability called a classification threshold. Examples with a probability above the threshold value are then assigned to the positive class, the class you are testing for, here spam. Examples with a lower probability are assigned to the negative class. Okay. Ooh. Okay. Okay, that just opens up this. You may be wondering what happens if the predicted score is equal to the classification threshold. For instance, a score of 0.5 where the classification threshold is 0.5. So I think that's what that's saying is like, let's say we get a score of 0.5 and sort of the border between spam and not spam is also 0.5. Handling for this case depends on a particular implementation chosen for the classification model. The Keras library, which I think is run by, which is the famous like machine learning library, predicts the negative class if the score and the threshold are equal. Oh, so it's like, oh, if we get 0.5 and the classification threshold is 0.5, then we say it's not spam. But it varies from model to model. I think that's what that's saying here. Oh, okay, a few more comments on this side. I like tea, but my favorite part of tea is the clotted cream, the scones. Ooh, wait, I actually haven't had a scone. There's a Starbucks nearby me, so maybe in the morning I'll get a nice cup of coffee. I'll definitely send a picture on the Discord if you guys want to see that as well. I love the little scones, or even cookies with tea are really nice. Hello, Shira Comic-Con. I think that's a new name. Welcome to the stream. Yes. Honestly, studying machine learning in the wee hours of the morning or evening in your case, honestly, kudos to you. It's always big brain hour, isn't it? Yes, hope I get better. Yes, thank you so much. I think my voice will get better. Learning physics from a VTuber is the last thing I expected myself, but here we are. Honestly, I am here to enrich the minds of the VTubing community. So this may be more and more common than you'd expect. Honestly, there is a growing science VTubing community as well. All right, let's keep going. Suppose the model scores one email as 0.99, predicting that the email has a 99% chance of being spam. Another email as 0.51, predicting it has a 51% chance of being spam. If you set the classification threshold to 0.5, the model will classify both emails as being spam. That makes sense, but I think... Oh, I guess we're going to go down there in a second, but I was going to say, like, there could be, like, false positives. Like, if you have an email that's 99% chance of being spam, classifying it as being spam makes much sense. But if it's 51% chance of being spam, then that's not really that high of a likelihood. Okay. 0.5 might seem like an intuitive threshold, but it's not a good idea if the cost of one type of classification is greater than the other. If only 0.1% of the emails are spam, labeling anything that the model considers at least 50% likely to spam produces undesirable results. Yes, exactly. Okay, let's go to the confusion matrix. That's a really scary name. The probability score is not reality or ground truth. There are 4 possible outcomes. Okay. Actual positive, actual negative, true positive, false negative, true negative. Okay, so let's read through each of these. Nebulous. Yes, I am very much into machine learning, but I have to admit that I'm a little bit of a beginner. I want to learn it a little bit more, and this Google machine learning course is sort of my way of learning this together with you guys. And along those lines, please feel free to ask questions, although I may not know the answers as I am also a beginner. This is all about learning and discussing together. Divye Joshi, yes, this is the machine learning course. It is also linked in the chat. Yes, confusion is already in the name, which makes me a little concerned, but let's take a look. So true positive, a spam email correctly classified as a spam email. Very nice. So this is sort of what we're aiming for. False positive, a not spam email that is misclassified as spam. These are legitimate emails that wind up in the spam folder. Honestly, this has happened to me way too many times, so maybe I need to adjust my, what's it called, the the classification threshold. False negative. A spam email misclassified as not spam. These are spam emails that make their way into the inbox. True negative. A non-spam email correctly classified as not spam. Very nice. I completed it. Oh, great. Wait, that's amazing. So we now have a TA for the course. Oh, if you've completed it last year, you may not know this, but they actually updated it in around August of this year, which is why we're going through it, and which is sort of how I encountered this course. So notice that the row, total in each row, gives all predicted positives and all predicted negatives, regardless of validity. When the total of actual positives is not close to the total of actual negatives, the data set is imbalanced. Okay, an example is a set of 1,000 photos of clouds where the rare cloud type you're interested in only appears a few times. Okay, so the imbalancedness is important. Oh, one other thing is that due to copyrights, I'm unable to play the videos for you guys, but please feel free to click the link and watch the videos in your own time. It'll also be a nice refresher. Different thresholds usually result in different numbers of true and false positives and true and false negatives. Okay. So let's try changing the threshold yourself. So this is our data. Separated, unseparated, imbalanced. Okay, let's go with separated first. And we said 0.5. Oh, wow, this is really nice. So we have predicted positive, actually negative, and so forth. So we can adjust this threshold. So if we have our threshold is 0.75, then many of them are true positives and true negatives. And we reduce our false negative, false positive population. But if we do like our threshold as 0.94, then we have not as many true positives and many more false negatives, because a lot of the values that should be true are now past this threshold marker. This is really useful. And we can also play around with this as well. Okay, let's actually read through the data sets. So the first one is separated, where positive examples and negative examples are well differentiated, with most positive examples having higher scores than negative examples. Okay. Unseparated, where many positive examples have lower scores than the negative examples. Oh, I see. Many positive examples have lower scores than negative examples, so they're a little harder to distinguish, I think. And imbalanced has only a few examples of the positive class. So I guess we can, I want to see what imbalanced looks like. So there's not many, so if we look at the whole data set, the positive examples are these clear squares here, and they seem to be only at the end. So even if we put the threshold up to this, there's going to be a lot of false positives because there's so few actually positive events. Very interesting. Okay, so let's do this mini quiz next. Let's check our understanding. It's quiz time. Let's imagine a fishing... Whew. Wow. That was a really big yawn. Whew. Imagine a phishing or malware classification model where phishing and malware websites are in the class labeled true, and harmless websites are in the class labeled 0. This model mistakenly classifies a legitimate website as malware. What is this called? So, in that case, in this case, harmless websites are labeled as false. And so, a false website is being misclassified as a true website. Which is malware. So in that case, we have, it's going to be a false negative, mayhaps, because so my thinking process for this is like, it's being misclassified, so it has to be a false something. So it's either C or D. but it's being misclassified as false, because it's being oh, no, that's actually untrue. The malware websites are being labeled as 1, true. Oh, thank you for Divya Joshi for subscribing. Oh my god. So the malware websites are labeled as true. So we're mistakenly labeling a false website as true. So is it false positive? Yeah, I think it might be a false positive because it's actually being labeled as 1. Oh, I thought it would like make us submit, but okay, let's go. Let's go. Victory Royale. Yes, a negative example. Okay, that's an easier way of putting it because my brain is so baked as in tired, by the way, this morning. A negative example has been wrongly classified as a positive example. Yes, that is true. Yeah, no, this is more of a word game. Wow, it's too early in the morning for me. I know you CET folks are... Maybe this is in the evening, afternoon for you guys, but for me it is 7:52 a.m. in the morning. So... the woes of Pacific time. Oh, hello, Phi the Neutrophil. Along the lines of finding more science VTubers, please go check out his channel. He does virus, immune system content. Very, very, very cool videos. Does lots of live streams. Very digestible, bite-sized videos as well. If you want to binge them all in one day, just like I did. Yes. Alright, let's keep moving. So... in general, what happens to the number of false positives when the classification threshold increase? What about true positives? So, if we go to the normal one. So when we increase the slider, the number of actually positive decreases, and the number of false positive... Wait, did they ask for false positives? The number of false positives. Okay, so let's move this back forward. So the number of false positives and the number of true positives also tends to decrease. That's because as we move our threshold, it seems like these squares, which represents the positives, also go back beyond the threshold. But we're also moving these circles, which should not be classified as true, into... behind the threshold as well. So we see both the true and the false positives decrease. Yes. As the thresholds increase, the model will likely predict fewer positives overall, both true and false. A spam classifier with a threshold of 0.999 will only label an email of spam if it considers the classification to be at least 99.99% likely, which means it's highly unlikely to mislabel a legitimate email, but also likely to miss an actual spam email. That makes sense. As we move the threshold forward, it's becoming less likely for us to label both legitimate emails and miss an actual spam email. 4:52 p.m. Wow, that must be a great time, though. That must be an amazing time. A morning class. Oh, hello, good morning, Fairy Dust Transmission. Very nice username. It's very, like, sparkle emoji coded. That's the only way I can describe it. Good morning. Yes, very early morning indeed. In general, what happens to the number of false negatives when the classification threshold increases? What about true negatives? Let's take a look. So... true negatives. So we're taking a look at these counters here. So let's move our thing back. So if we move the threshold forward, the number of true negatives and the number of false negatives are increasing. And that's because more things are being put beyond this threshold onto the left side. regardless of whether or not it's a circle or a square, regardless or not it's a positive or a negative. So both the true and false negatives are increasing. As the threshold increases, the model will likely predict more negatives overall, both true and false. At a high threshold, almost all emails will be classified as not spam. Great. All right, moving on. So now we are on this section. Let me just mark that real quick. Classification, accuracy, recall precision, and related metrics. True and false positives and negatives are used to calculate several useful metrics for evaluating models. Which evaluation metrics are most meaningful depends on the specific model and the specific task, the cost of different misclassifications, and whether the dataset is balanced or imbalanced. All the metrics in this section are calculated at a single fixed threshold and change when the threshold changes. Very often, the user tunes the threshold to optimize one of these metrics. Okay, very interesting. Let's go on to accuracy. But before we do that, reminder to hydrate. I have my water bottle here. So I have cold water in this bottle. And warm tea in this cup. So my throat is like totally just rejuvenated. Yeah, for those of you who came late, my throat is not in the best condition right now. I guess that just means I need to go back to drinking 3 or 4 cups of coffee a day. I'm just joking. Unless, who knows? I don't know. I don't know what the average cup of coffee consumption should be, but I think I'm above average right now. Honey helps a lot. Ooh, that's actually a great suggestion. I'll need to find some honey somewhere. I've also been drinking like hibiscus tea, which has been a little helpful, and these little like lavender supplements. Apparently they're really helpful as well, and they taste really delicious too. All right, let's keep moving. Accuracy is the proportion of all classifications that were correct, whether positive or negative. It is mathematically defined as accuracy is equal to correct classifications over total classifications. Okay, so these mean true positive plus true negative over basically all of the classifications. So in the spam classification example, accuracy measures a fraction of all emails correctly classified. So a perfect model has 0 false positives and 0 false negatives at an accuracy of 1. Because it incorporates all 4 outcomes from the confusion matrix. Now that I think about it, that was called the confusion matrix, but it wasn't really that confusing at all. I mean, I have to get used to the terms, but I thought it would be more scarier than that. Given a balanced dataset with similar numbers of examples in both classes, accuracy can serve as a coarse-grained measure of model quality. Okay, cool. However, when the dataset is imbalanced, or where one kind of mistake is more costly than the other, which is the case in most real-world applications, it's better to optimize for one of the other metrics instead. I think one example that comes to mind is like a disease test. I mean, you could obviously take a test twice, but I've heard of instances where it's really important to get the, like, whether or not you have a disease correct, because it could determine, like, for example, like, a blood type test. If you do that only once and it gives you the wrong result, then that's not good at all, is it? For heavily imbalanced dataset, where one class appears very rarely, a model that predicts negative 100% in time would score 99% on accuracy despite being useless. Yeah, no, that's true. I think one example is, like, I saw a instance where the Zika virus is, like, very rare in some communities, and despite the test giving back, oh, you have Zika, the actual chance that you have Zika despite that test might only be like 9%, even if the test accuracy is over 90%. Really interesting applications. I'm sure they'll give much better examples than the one that I just gave, but good food for thought. Apparently anything under 400 milligrams of caffeine a day is beneficial. What about anything over 400 milligrams of caffeine a day? If you can find chrysanthemum tea, ooh, I'll write that down. Chrysanthemum tea. Maybe this is about time we start a tea channel in the Discord. What do you guys think? Honestly, I would love to discuss types of tea. I have actually a whole section of my residence that is sort of like a barista slash tea distribution corner, and I have a lot of tea. Let's keep moving. Heart palpitations, let's go. Although I have to admit, my coffee addiction is not as bad as it used to be. Right now, I'm averaging maybe like 1 or 2 cups a day. At my worst, I was 5 cups a day. So please do not go down that rabbit hole. It is very, very, very bad. I know one of my friends had to take caffeine pills to get off of coffee or Coca-Cola or both. So not very good. Okay, recall or true positive rate. The true positive rate is a proportion of all actual positives that were classified correctly as positives, also known as recall. So that's true positives over true positives plus false negatives. So false negatives are actual positives. So we're taking all of the positives, and on the top is the correctly classified true positives, which is why they appear in the denominator. In the spam classification example, recall measures the fraction of spam emails that were correctly classified as spam. This is why another name for recall is the probability for detection. It answers the question, what fraction of spam emails are detected by this model? Okay, because it only looks at positives, which are spam. Okay, a perfect model will be 1. Great. The false positive rate is a proportion of all actual negatives that were classified incorrectly as positives, also known as a probability of false alarm. It is mathematically defined as the false positive rate is equal to incorrectly classified actual negatives, so false positives, over all actually negatives. Well, fortunately, the name is not that confusing, because you know to put false positives in the numerator, but you put all actual negatives in the denominator. So measure the fraction of legitimate emails that were incorrectly classified as spam. Okay, great. In an imbalanced data set where the number of actual negatives is very, very low, FPR is less meaningful and less useful as a metric. Okay, interesting. Tea is like the default cultural gift for us. Anytime we go home, it's mountains of tea. Wait, that's so funny. Yes. Whenever I was in Japan too, tea is I feel like going to Japan actually sort of reshaped my view on tea. It's not just something that you might find like in a cafeteria or just like the really cheap ones that you can find at like Target or Walmart. But when I went to Japan, I did a tea ceremony, and it's a very detailed, a very sort of relaxing, cozy experience. It's supposed to represent peace. You're supposed to kneel on the tatami mats until your knees hurt so that you can't suddenly like jump up and jump scare somebody, or get out your sword and fight. I'm sitting at like 3 cups a day. Ruh-roh. No. The tea train is much, much better. And I heard that matcha is much better than coffee because the caffeine sort of rises over time. You don't experience like a sudden sugar rush and a sugar crash, per se. I definitely want to get more into that. I did buy some really nice tea. I bought this wedding green tea, actually. That's really good. I'll take a picture of it later. Maybe I should drink some of that later today. Okay, let's look at precision. Precision is the proportion of all models' positive classifications that are actually positive. It is mathematically defined as so actual positives over everything that is classified as positive. So this is sort of the positive rate. This is the okay, so this is very different. So this is the positive rate over everything classified as positive. So in the spam classification examples, precision measures the fraction of emails classified as spam that were actually spam. Wow, okay, so it seems like there's a lot of vocab words. I'll definitely have to scroll up later and refresh myself. But let's just keep going. Precision improves as false positives decrease, while recall improves when false negatives decrease. but as seen as the previous section, increasing the classification threshold tends to decrease the number of false positives and increase the number of false negatives. So as a result, precision and recall often show an inverse relationship. So let's go back to recall. So recall is our true positive rate. So these are actually different. So they both have true positives in the numerator, but the denominator is different. So recall has all actual positives, and precision has everything classified as positive, whether or not it's actually positive or not. Wow. Okay, this is a little confusing, but let's just take a look at these, and maybe the questions will help. Okay. Oh my god, my voice is definitely dying. Need a little bit more coffee. Or tea, in this case. Blackberry is what I normally drink, but I should... Ooh, blackberry is really good. I actually heard that blackberry also has some good, like, attributes for the immune system, so maybe I should drink some of that too. Kelp toast, I'm so basic on the tea game. Green, black, oolong, and Earl Grey. I do like green a lot. Yeah, no, honestly, I feel like I like that it's that basic, though. Because honestly, it's... Even if you don't know that much about tea, there are different benefits of each. Like, black tea is usually more caffeinated. I feel like Earl Grey also has a lot of caffeine, but I was talking about this, like, smoked Earl Grey tea earlier, and there's, like, lots of different flavors. And for green, I definitely recommend, like, they sell, like, green tea that's mixed with different things. For example, they have, like, strawberry green tea, blackberry green tea, and so forth. Oh, hello, Niranja Nair. What is this P content? We are going through the classification Google machine learning course that is linked in the chat. So we're progressing through it. Let's keep on moving. What does non mean in the metrics? Where was that? Oh, okay, so if I do this, then we see the precision is non. Non or not a number appears when dividing by 0, which can happen with any of these metrics. When the true positive and false positive are both 0, the formula for precision has 0 in the denominator. I see. So that's sort of what that means. So if we adjust, so let's say the threshold is 50%, the accuracy is 0.85, but... Oh, so we can actually see how it changes. Oh, so after this point, the precision is 1. Because everything after here is a square. It's 1. So that's great. But we can also see that accuracy increases as we move right. Whereas recall seems to decrease. So, yeah, this is also linked in the chat. So feel free to play with this as much as you'd like. So choice of metric and trade-offs. Okay, this is really useful because I feel like there's a lot of terms here and I'm getting a little confused. The metric you choose to prioritize when evaluating the model and choosing the threshold depends on the costs, benefits, and risks of the specific problem. In the spam classification example, it makes sense to prioritize recall, nabbing all the spam emails, or precision, trying to ensure that spam-labeled emails are in fact spam, or some balance of the two above some minimum accuracy level. Okay, so I think what I'm quickly going to do is read through this chart. F1 score, Formula 1 score. Okay, give me one moment. Okay, we're all good. Okay. That blackberry green. Blackberry is preferred due to my immune deficiency. Yes, no, exactly. Maybe I need to drink some of that right now. Blackberry green tea sounds pretty good. Everybody is getting sick. Yeah, no, everybody stay safe. I know COVID is making its rounds again in some places. Can you spend a minute and provide a roadmap for DSMO? Not sure what that is, but if you're following along, we are currently here in the course itinerary, so feel free to review it. I know that maybe at the end there's a bit of a recap. So let's go through this table. Accuracy uses a rough indicator model training progress. So That was this one, which decreases as we move. Oh, I guess it actually sort of evolves. It increases, then it decreases as we move right. For a model performance, use only in combination with other metrics. Avoid for imbalanced datasets. Consider using another metric. I see. Recall. Use when false negatives are more expensive than false positives. False positive rate is used when false positives are more expensive than false negatives. And precision used when it's important for positive predictions to be accurate. I see. This is really useful. So the optional advanced F1 score. Oh, Daraja Dare. F1 score basically helps mitigate the problems with precision and recall. Oh, I see. It's some sort of harmonic mean. Interesting. Great to see we have another TA in the chat. Whew. Be sure to stay hydrated. All right. Exercise. Check your understanding. A model outputs 5 true positives, 6 true negatives, 3 false positives, and 2 false negatives. Calculate the recall. Okay, so let's go back to our equations here. So we said that recall is the correctly classified actual positives over all actual positives. So what fraction of spam emails are detected? So what fraction of positives are detected by this model? So we take the true positives in the numerator, so 5 divided by the true positives plus false negatives, which represents the total number of positives? No. It represents all actual positives, because the false negatives were positives that were misidentified as negatives. So recall would then be 5 over 5 plus 2, which is 7. Which I think is 0.714. But let's quickly check. Yes, it is 0.714. Yes, there we go. A model outputs 3 true positives, 4 true negatives, 2 false positives, and 1 false negative. Let's calculate the precision. So let's go back to our little equation here. So the precision is correctly identified actual positives over everything that is classified as positive. Okay, so that was what I was confusing with earlier. So we take 3 in the numerator, which represents the true positives, and then we do 3 plus 2 is equal to 60% as the precision. That's 3 over 5. Yep. Let's go. And then you're building a binary classifier that checks the photos of insect traps for whether a dangerous invasive species is present. If the model detects a species, the entomologist or the insect scientist on duty is notified. Early detection is critical. A false alarm is easy to handle. The entomologist sees that the photo was misclassified. So false positives are okay. False negatives are not good. So we want to avoid false negatives. So in that case, we want false negatives are more expensive than false positives. So we would want to use recall. Yes. In this scenario, false alarms are low cost because the entomologist can go and just check it. But false negatives are costly because we would miss an early detection. So it makes sense to maximize the recall or the probability of detection. Great. And that's the entirety of this section, accuracy, recall, and these metrics. So I think I'm personally going to go back and definitely refresh myself on these because that seemed like a lot of content. But let's move on to the next section. Classification, ROC and AUC. Let's learn about what these are. And if you all have any questions, please feel free to put them in the chat. Although I have to admit that I myself am also a beginner. So I might not be able to answer your questions, but it seems like there's a few people in the chat who have done this course or are familiar with machine learning. So you guys can be the designated TAs for this course. and I'll try my best to also answer any questions that are available. Okay. Let's go at ROC. Receiver Operating Characteristic Curve. The ROC curve is a visual representation of model performance across all thresholds. The long version of the name, Receiver Operating Characteristics, is a holdover from World War II radar detection. Wow, really interesting stuff. I actually didn't know that. The ROC curve is drawn by calculating the true positive rate. Oh, my eye is very scratchy. And false positive rate at every possible threshold. Then graphing the true positive rate over the false positive rate. A perfect model which some threshold has a TPR of 1.0 and a false positive rate of 0.0 can be represented by either a point at 0, 1 or by the following. So for a perfect model, I mean, it's just 1. Because the true positive rate, which means we're correctly identifying positive values, is 100%. We have no false positives. Okay. So the area under the ROC curve represents the probability that the model, if given a randomly chosen positive and negative example, will rank the positive higher than the negative. The perfect model above, containing a square with size length 1, has an area of 1. This means that there's a 100% probability that the model will correctly rank a randomly chosen positive sample higher than a randomly chosen negative sample. Great. In other words, looking at the spread of data points below, AUC gives the probability that the model will place a randomly chosen square to the right of a randomly chosen circle, independent of where the threshold is set. I see. In more concrete terms, a spam classifier with an area under the curve as 1 always assigns a random spam email a higher probability of being spam than a random legitimate email. I see. Okay. I think this makes sense, although I want to look at other examples where it's not necessarily 1, just to make sure I have my understanding correct. In more concrete terms, a spam classifier with AUC of 1 always assigns a random spam email a higher probability of being spam than a random legitimate email. The actual classification of each email depends on the threshold that you use. For a binary classifier, the model that does exactly as well as random guesses or coin flips has an ROC that is a diagonal line from 0 to 1. The AUC is 0.5, representing a 50% probability of ranking a positive and negative sample. That makes sense, because we're looking at the area under the curve as 0.5, but the true positive rate and the false positive rate goes from 0, 0 to 1, 1. So it assigns a random spam email a higher probability of being spam only 50% of the time. I think that's a really good way of sort of phrasing it. Okay. So let's take a look at these curves even further. AUC and ROC for choosing the model and the threshold. Okay, AUC is a useful metric for comparing the performance of two different models, as long as the data set is roughly balanced. So the model with a greater area in the curve is generally the better one. And that's because we want the area to be 1. We want the true positive rate to be better. We don't want that much false positive rate. So clearly for this example, the one on the right is definitely better. It looks more like 1. The points on the ROC closest to 1 represent a range of the best performing thresholds. As discussed in these sections, the threshold you choose depend on which metric is important to the specific use case. So if you have these points here, each representing a threshold, if false positives or false alarms are highly costly, it may make sense to choose a threshold that gives a lower false positive rate. Oh, I see. Oh, that's really nice. So this point A here, oh, I guess you can't see my cursor, but if you look at point A, it has a lower false positive rate than B or C, which are sort of further along on the x-axis, even if TPR is reduced. But yes, the disadvantage to using A is that it has a lower true positive rate, but if we want to avoid false alarms, that is sort of our best choice. On the other hand, if false positives are cheap and false negatives are more expensive, then we would use point C, which is sort of further along the false positive rate x-axis, but the true positive rate is much higher. Oh, nice. So we can actually sort of play around with this threshold here. So it's a little hard to include this on one screen, but so let's say the threshold is here, then the dot is here, and we can move it along. Oh, I see, and you see the dot that's like moving a little bit to the left. Ooh, that's really cool. So if we want to avoid false positives, we would move it over here. And that makes sense because the threshold, we have the threshold being higher, and everything past here is a square. There's no false positives. Whereas if we want to just make sure that we detect anything, even if that means having false negatives, which are these x'd out circles, we notice that the dot is further along to the right. That seems to make sense. So it's like adjusting the threshold, adjusting the risk of a false positive, true positive rate. And now we're at the exercise section. Let's check our understanding. So in practice, ROC curves are much less regular. Which of the following has the best performance? We definitely want one with the greatest area under the curve. So this one. Yeah, that's pretty self-explanatory. We just want big area under the curve. That's sort of what I'm thinking about. Which of the following models performs worse than chance? So we have area in the curve 0.32, 0.5, 0.508, or 1. Well, when it means performing worse than chance, I assume that means performing less than 50-50. So we want the area under the curve. We're looking, I'm thinking it's this one because the area under the curve is less than 0.5. Yes. Bonus question. Imagine a situation where it's better to allow some spam to reach the inbox than allow a business critical email to the spam folder. You've trained a spam classifier for this situation where the positive class is spam and the negative class is not spam. So we want more things to be positive. It's better for something to be oh wait, no. We want more things to be negative because we don't want something that's accidentally being classified as spam. So we want more false negatives. In that case, we would want the false positive rate to be lower. Because a false positive means that something's being misclassified as spam. So I think we should go for point A because it's more leftmost. Yes. In this use case, it is better to minimize false positives even if true positives also decrease. Basically, we just need to detect, we need to decrease the amount of things being classified as spam, which is positive in this case. That's really confusing. I feel like when I think of spam, I associate that with being negative and legitimate emails being positive. I don't know. Am I in the wrong here? What do you guys think? Shouldn't the curves be a mean between the different data sets? Do you mean like... Oh, do you mean like... I think what this actually just represents is just plotting the true positive rate versus the false positive rate for a single data set. Is that what you mean by mean? I guess while we're waiting, we can move on to the next section, prediction bias. Oh, this is really short. As mentioned in the linear regression model, calculating prediction bias is a quick check that can flag issues with the model or training early on. Prediction bias is the difference between the mean of the model's predictions and the mean of the ground truth labels and data. Maybe PogChamp Senpai, this is what you might be interested in. A model trained on the dataset where 5% of the emails are spam should predict, on average, 5% of the emails it classifies as spam. That makes sense, because like, what if the model is like, okay, let's say we found that 100% of the emails are spam, but we know only 5% are, then definitely it's wrong. So the mean of the labels in the ground truth dataset is 0.05. And the mean of the model's predictions should also be 0.05. If this is the case, the model has zero prediction bias. Of course, the model might still have other problems. So we want these two to match. Doesn't a single ROC curve depend on a single data set? Yes, I think that was what we were looking at the examples. If the model instead predicts 50% of the time that an email is spam, then something is wrong with the training data set, the new data set the model is applied to, or with the model itself. Okay. Any significant difference between the two suggests that the model has some sort of prediction bias. Okay, so we want no prediction bias. So prediction bias can be caused by bias or noise in the data, too strong regularization, meaning that the model was oversimplified. Bugs. Bugs are not good. The set of the features providing the model being insufficient for the task. Okay, very good. Oh, you got it. Okay, thank you. Okay, great. Very good, very good. I actually heard a joke the other day that the reason why computer scientists don't like going outside is because there's bugs in nature. Sort of funny. Let's see. So now we're at multi-class classification, and there is a brief programming exercise, but we could skip that and probably go to the quiz and then save the programming exercise for next class. What do you guys think about that? Or do you guys want to go in order? And we can see if we have time for both, but I think we might only have time for one or the other. We can save the programming exercise for next class and then get started on this data section. What do you guys think? Classification, multi-class classification, can be treated as an extension of binary classification to more than two classes. Okay, so if we have more than just spam or not spam, we're like A, B, and C. If each example can only be assigned to one class, then the classification problem can be handled as binary classification problem, where one class contains one of the multiple classes, and the other class contains all the other classes put together. Oh, interesting. So, okay, let's look at this example. In a 3-class multi-class classification problem, that's a total word jumble, by the way. That's a tongue twister. Where you're classifying examples with the labels A, B, and C, you can turn the problem into 2 separate binary problems. So first we do A plus B, then C. And then we go through the A plus B stuff, and then we organize into A and B. Oh, an example of a multi-class problem is a handwriting classifier that takes an image of the handwritten digit and decides which digit 0 to 9 is represented. I did not know that was like using this type of method though. If you haven't already, you guys should go on the Discord. I did send the website to a really cool interactive website that lets you draw a number and shows how a neural network classifies it into 0 to 9, like identifies the digit. I might send it out afterwards, so let me just label that later. And then I definitely want to share that network. I'm jotting these down, so I'm remembering to send it later. Woohoo! Yeah, the website was super, super cool. It was really well made, and it was also really fun to play with. Okay, so we're gonna skip the programming exercise for now, and maybe go straight to the quiz. Oh, whoa! New website. Ooh. Okay, let's keep on moving. I may need to head out in a little bit, but I think we have just enough time to cover this quiz. And also, we will also have a stream tomorrow, so you will be seeing much more of me soon. So, yeah, it should be alright even if this stream ends a little early. Classification. Dun dun dun. You must answer at least 4 questions correctly to pass this quiz. And there's 5 questions, so there's no room for error, guys. Alright, let's go. Increasing a binary classifier threshold value is likely to produce which of the following effects? We just saw this. This was in like the first exercise. We saw that false positives and false negatives. So as we increase the threshold value, we saw a lot of things going to the left of the bar. So I think both the false positives and the false negatives would both decrease. We know the false negatives. No, when we move the threshold to the right, there are less things that are being that are actually true that are to the right. But I thought false positives would decrease and false negatives would increase. But that's not an option. Well, worst case scenario, we can retake this quiz. So I think it might be that both false positives, or maybe it's just that the false positives would decrease. This is a bit of a tough one. Maybe A. Maybe A. I'm thinking right now. Maybe this should be a new emoji. Thinking face. False positives. I think the false positives would decrease though. I think the false positive would definitely decrease because less things are going to be to the right of the bar. But I think false negatives. I would put B for now, but we can always go back or retake the quiz. The data set that you split into train, test, and evaluate sets has 9,998 negative samples and 2 positive examples. And the resulting model has an accuracy metric of 99.9%. Call Crypta for the emoji. Calling Crypta right now. Crypta, if you are in the chat. Wow, I'm really projecting. Well, Crypta, wherever you are, please be sure to make a new emoji. Oh, hey, we back? Yes, we are back. Oh, actually, I don't think I've seen you back yet. We were just finishing up the Google Machine Learning course. We're going through this quiz. The data set that you split into train. Oh my god, Crypta! Hello! Hello, greetings. Perfect timing. Perfect timing. We were thinking that you could maybe help assist making an emoji that looks a little bit like this. Hold up, my model's like glitching out. Whoa, my hand is like throwing gang signs. Hold up. Wait, actually it's better if I do it with the right hand. Oh my god, it's like covering my face. Something like this. Okay, that should be pretty helpful. Okay, let's keep on moving the quiz. The data set that you split into train, test, and evaluate sets. Okay, so what is 2 divided by... What is 9,996 divided by 9? So the actual percentage of positive examples is 99.97%. So this is actually higher. But I think, I mean, it is kind of off by 0.1%. Everybody put the thinking emoji in the chat, please. This is a bit hard. I'm gonna say no just to be safe, but we can always retake this quiz. Yes, Crypta, you have been enlisted to create the emojis. In general, when precision increases, what happens to recall? So we had, I think precision was true positives over everything classified as positives. Recall is true positives over everything that's actually positive. So when precision increases, that means that the number of true positives increases. Wait, but that's so, True positive over... This quiz is quite difficult. I mean, we could go back and check what recall is. I think that's the one thing that keeps confusing me. So recall is, yeah, true positives over all actual positives. Precision is true positives over everything classified as positive. So when precision increases, that means that we're having more decreasing the false positive rate. So I think recall would actually decrease because the false negatives would probably increase. Because if precision increases, we're doing a much better job of we're basically classifying things more likely to be actually positive as positive. Maybe recall decreases. What do you guys think? This is actually kind of a tough quiz. A little bit of also a word puzzle as well. The points on a binary classification model's ROC curve closest to 1, 1 generally represent the best performing thresholds for the model. So the upper right corner. I don't think that's true because we saw in the previous examples that we can play around with where the thresholds are. You are evaluating the performance of 2 binary classification models. Model A has AUC of 0.5. Model B's predictions are made completely randomly. Which of the following statements are true? Model A performs better than Model B. Model A and Model B perform equally well. Well, if Model B's predictions are made completely randomly, doesn't that mean it's 50%? So wouldn't it be 50%? Maybe. Or maybe because it has an AUC, it's already a little bit better. I'll say equally well. I have to be honest, I'm only confident about one of these answers. This is a pretty challenging quiz. But even if it is incorrect, we can always retake it. And this is all about learning. Yes, feel free to answer. What do you think? Hello, Ginger HRN, by the way. I think you're a new viewer, so welcome to the channel. Yes, feel free to provide suggestions. Yeah, no, this is a bit of a challenging quiz. I feel like I'm also a little confused by the wording of things. So we can just go through this again. Increasing a binary classifier's threshold value is likely to produce which of the following effects? I said that the false, I'm just thinking that the false negatives would increase. The real test is explaining the concepts of the finance bro who controls budgets. Exactly. Well, I'm pretty sure they all have machine learning training probably, right? Right? I mean, we can try submitting this, and even if they are marked as incorrect, we can sort of go back and check. What do you guys think? Maybe we should just submit it. What? Oh my god, what? I had zero confidence on this quiz. How? Honestly, I think this is worth sharing on Twitter or X or whatever. Sheesh. Okay. Wow, okay, I will definitely post this on Twitter. Those of you who are here, you guys are the real ones. You guys are the real ones. We will celebrate this. This is the biggest achievement of my channel. Earning the Machine Learning Crash Course Classification Badge. Amazing. Let's go, hey yo, let's go. They barely have counting training. That's so funny. Wow, you deserve coffee. Yes, no, I definitely do. You know where I'm going right after this? Straight to Starbucks. Straight to Starbucks. I honestly wish that there was a smaller local cafe that was near my place, but Starbucks is really the only one. But they have interesting pumpkin drinks. Honestly, I'd be down for a straight cappuccino right now. Wow, this was... Wow. You have witnessed the moment for real. Even the Shibe. Even the Shibe is dancing. Woohoo! Let's go! Let's go! Let's go! The Zybe. Oh. Oh, okay. Here, I'll leave this open for us to celebrate later. And then, yeah, so we'll do the programming exercise next machine learning stream. Oh, okay. And we already did the quiz. Oh. Congrats on finishing the model. Okay, great. Yeah. And so during the next stream, we'll be starting the data section. So we just finished the ML model section. Let's go. And then we'll be working with data next, which I'm pretty sure we'll also have some really cool exercises as well. Yay. All right, great job, everybody. I think that's going to be the end of this stream. So I hope you guys learned a lot. And also the course is linked in the chat again, so please feel free to go through that. And yeah, wow. How are you guys feeling? Energized? Because I certainly am. And my voice is already doing so much better. Maybe it's because of all the talking. Maybe this is a sign I should stream more. Oh, and along those lines, I do have a super special announcement. Super special announcement. Tomorrow, I will actually be streaming again. Time is still TBD, but it'll be around 11 a.m. PST or 12 p.m. PST. I think probably around 11. And we will be playing. Well, you guys might want to guess what we're playing. Drum roll, please. We'll be playing Superliminal, which was gifted by Crypta on my Throne account. So thank you so much to Crypta. This is a game that I've actually wanted to play all the way back during COVID, actually, when a lot of the Hololive Myth people, including when I first encountered Ame, were playing it. So this will actually be the very first gaming stream on my channel, and I think there's no better way to commemorate it than the big brain game itself. So yes, I'm very excited to play the game, and thank you Crypto once again for the game itself. Actually, along those lines, Crypto also gifted Buckshot Roulette, which is another game that I might want to play, but I'm actually thinking that the stream after Superliminal might be an unboxing stream. And the reasons for that is because some of the gifts have arrived in the mail. Now, I'm still receiving a few of them, but I would love to do a hand cam unboxing event. And the good news is that I just also have gotten a webcam. So this will be great. I have all the necessary ingredients for this stream. So that might be sometime next week, which would be very great. Oh, hello, Anas099. I am AI tutor stream. Yes, I am not AI though. I would like to keep that in mind. I'm not AI. I'm a real person. But welcome. Actually, you're coming just about at the end, but I promise you the VOD will be up probably immediately. It was very interesting and clear. Thank you so much. I mean, it's all really the course. I'm also learning alongside you guys. So, yep. I will also mayhaps be creating a new tea channel in the Discord. So if you want to suggest your tea ideas there, and I'll take a picture of some of the teas I have too in my little barista corner of my residence. So yeah. I hope you guys enjoyed the stream. So have a great day or evening or whatever time zone you're in, class. All right. Well, I will, I guess, see you tomorrow. I can't believe I can already say that. It's Saturday tomorrow. So have a great Friday, or maybe some of you guys are already at a Saturday. So have a great Friday. Go drink that cup of coffee. Go get that rest. Make sure to digest the information of this course overnight, and so forth. Discord link should be in the description. Otherwise, I will also send it out on the Twitter if not. Or I'll also edit the description to have it in the link. Oh, a better Zai PNG. Yes, huge thank you to Eggy for drawing these. Thank you. Also, thank you so much, Eggy. I have to admit that this really made my day. I mean, it's so adorable. So cute. And I also like the black Zybe as well. Alright, thank you guys so much for joining. Have a great day. I will see you tomorrow. Bye bye.